I'm going to show you how I manage sensitive data for all of my projects across the entire stack. But keep in mind that the exact tools that I use in this video are of less consequence than the methods. All the code samples for this video come from this GitHub repo. And lest I forget, links for this and any other URLs that you see in this video are all in the description section below. Okay, let's get into it. Your remote services usually require authentication with some kind of a secret key, so this falls into factor number 3, config, of the 12-factor app approach. Typically, your project exists in multiple environments like dev, staging, and prod, and your credentials might vary for each of these stages. Ideally, you write your code so that it's agnostic to the environment in which it runs, and as long as that's true, then you're all set on factor number 3 of the 12-factor method. And if you're interested in seeing how to actually implement the 12-factor app methodology, then I created this video that explains how it's implemented in the same repo. But back on topic. Typically, I'm working with multiple credentials that need to be merged into a single file, like the .env file that we're using in today's example repo. To do this well, you'll need a CI/CD automation tool. There's a lot of platform options, and frankly, for what I do, they're all pretty homogeneous. This video is not sponsored, but for what it's worth, I mostly use GitHub Actions because A, I can add the workflows to my repo, B, it's mostly free, C, it has all the features that I need, and D, it seamlessly integrates to other free GitHub services that I also use. Note, for example, that GitHub also has a great secrets feature where you can paste in a credential as Unicode text, and then it becomes available from inside of GitHub Actions as a kind of system variable. You can create these secrets for a repo or organization-wide, and either way, you use the same syntax inside of your GitHub Actions workflow. The secrets are read-only and invisible once you create them, and so that's nice as well. GitHub Actions workflows are written in YAML, and the syntax is intuitive and it's easy to learn. To use a GitHub secret in your workflow, the basic pattern is A, retrieve your secrets, B, merge these into your configuration file, and then C, push and persist these to their runtime location for the environment that you're deploying. The important thing is that the process is automated, meaning we never have to touch it ourselves, and also that the secret itself is never exposed at any point during a deployment. A .env file, by the way, is a text file whose contents are in key value format. The basic idea is that your application reads this file, if it exists, and it assigns the values to variables inside of the application. It's simple and effective, and it works for any language. By the way, Terraform natively supports terraform.tfvars, which effectively is the same thing. A couple of suggestions for using .env files for your project. First, don't forget to add .env to git ignore so that you don't accidentally commit and push this file to GitHub. And also, you can use this pattern inside of a makefile to automatically scaffold your .env file for you by simply running the command make in the root of the repo. Customarily, you'll create your .env file in the root of your repo, but just so that you know, the third-party libraries for all popular languages like Python and JavaScript do a folder tree traversal to look for the .env file. So it'll find it as long as it's located anywhere from the current working folder up to the root of the project. Here are Python and JavaScript examples. It's as simple as installing the package with pip or npm, as the case may be, importing the library, and then calling a single line of code that looks for your .env file and then sources the values, creating and initializing bash environment variables for each key value pair. .env is a great approach because it's really simple and it's operating system independent. If you're finding this useful so far, then also please consider subscribing to the channel so you can see more great videos just like this one. And if there's something specific you'd like me to talk about, then leave a comment down below. Inside your cloud environment, your backend services generally should be requiring authentication between each other, even though ideally they're placed on a private network that does not provide public access. When possible, I handled this kind of authentication using role-based security, which, though more complicated to implement, simplifies keeping track of the attack vectors inside of what typically is a meshed grid of clients and servers inside of your VPC. Otherwise, the credentials that these back-end services require will end up inside of the configuration data for whatever application they back. On large platforms, I generally use both approaches. Moreover, there's this idea of the zero trust security model that I try to follow as much as is feasible for whatever I'm working on, but keep in mind that this adds complexity and cost to your project, which is why you won't typically find live projects fully implementing this scheme. But designing, implementing, and managing something like what I'm describing is actually pretty complicated. A few years ago, I switched to designing and implementing everything with Terraform. The tangible benefit to using an infrastructure as code approach is that you can use an intuitive, declarative approach to configuring your cloud infrastructure, which makes complicated stuff like network design a lot more manageable, especially after you've gone live. Let's go through an example and I'll show you what I mean. You can easily spin up an AWS relational database service for, say, MySQL Server using this can Terraform module that incidentally is managed by AWS. It gives you the option of creating a random password for the root user. And so once you've created that resource, you can reference it in any of the RDS module's other output variables like this on a command line where you have access to kube control API and the Kubernetes cluster. Or like this inside a Terraform source code. Here's how that would work. You can use this Kubernetes secret data declaration to retrieve the data from the actual Kubernetes secret store, and then reference this data elsewhere in your Terraform code. Finally, you can do something like this, where you leverage Terraform's templating tools to set up a bash script that contains your secrets values and then executes this script inside of some server instance via an SSH connection, and then everything gets wiped clean when you're done. All those vars declarations become bash environment variables that get referenced like this, for example. But the special folks, like admins and data science people, have to be able to access these backend services, and this requires some foresight given that, hopefully, all these services are running inside a private network. My workaround to this is to create what I refer to as a Bastion server, which is a small, like T3 micro-sized Linux virtual server that runs on a public subnet, and it has port 22 selectively open for private key authentication. I can create private keys for individual admins as needed, and they can access whatever services they need via this Bastion. The simplest way for them to do this is via terminal shell access, but there are also some applications like MySQL Workbench, for example, that provide seamless connectivity to backend services via an SSH tunnel. I deploy solutions 3 different kinds of ways these days: serverless, Kubernetes, and the traditional Linux server instances that could be either in the cloud or on-premise. And believe it or not, my methods for managing sensitive data don't really vary that much, if at all, from one kind of environment to the next, because each of these 3 kinds of environments understands the concept of an environment variable. We're covering front-end best practice at the end of this video because it's something of a conundrum. If your solution is browser-based, then be aware that all the resources delivered to the browser are completely exposed. And also be aware that it's fairly trivial to write an app that crawls the web and uses a regular expression to ferret out common sensitive data like AWS key pairs and OpenAI API keys. So don't ever bundle your secrets in your JS code, nor anything else that gets delivered to the browser for that matter. And that's it. Thank you for watching. I hope you found that helpful. And if you did, please like and subscribe. And either way, I will see you in the next video.